Good day, ma'am, and to all the judges. I am Dina Honorio, a researcher of 10 Uranus. The research that we will be defending is the growth and yield of sweet potato as affected by different levels of salinity. Salinization of soils has become a global environmental problem and is an important factor limiting agricultural productivity. Lowland areas have been affected by desalinization due to salt water's intrusion as one of the effects of the rising sea level due to global warming. This phenomenon has threatened the yield of most agricultural crops that cannot tolerate high salt concentration. As salinization threatens crops and ecosystems, farmers and policymakers seek solutions. Thus, proper management and a good selection of crops to be planted should be made to maximize land's potential under such conditions. Sweet potato Ipomoea batatas is a warm season root crop. It is one of the most promising crops and can substitute for rice as a staple food. The sweet potato could be considered as an excellent novel source of natural health-promoting compounds such as beta-carotene and anthocyanins for the functional food market. Starch and flour processing from sweet potato can create new economic and employment activities for farmers and rural households and add nutritional value to food systems. Therefore, this study looks at the growth potential and tolerance level of sweet potatoes under saline soil. This study hypothesized that sweet potatoes could grow and give the highest yield at a certain level of salinity. Objectives of the study. In general, this study aims to determine if sweet potato could thrive under saline soil. Specifically, this study aims to evaluate the effect of varying levels of salinity on the growth of sweet potatoes. This study aims to assess the yield potential of sweet potato grown in soil with varying salinity levels. Scope and limitations. This study focuses on the growth and yield of sweet potato at different salinity levels using one variety only, which still has to be identified at field root crop. Time and place of the study. This study will be conducted at the experimental area of the Department of Soil Science, Visayas State University, Vizca Baybay City, Leyte, from March to July 2021. But as of now, we cannot set the exact date to conduct our research study due to pandemic. Process flow in the conduct of the experiment. Preparations of the equipment and materials. The materials that will be used in the study will be 18 pieces of sweet potato cuttings, 5 kilos sandy soil, 5 kilos of sodium chloride, 75 liters of water, and an organic fertilizer. The equipment and utensils that will be used in the preparation of growth and yield of sweet potato as affected by different levels of salinity are as follows: polyethylene pots, basin, and wire mesh. Soil sample collection and preparation of soil medium and potting. Bulk sample from the 0 to 20 cm layer of sandy soil will be collected in Vizca Baybay City, Leyte. To any treatment, the bulk soil sample will be air dried and will pass through a 10 mm wire mesh for the preparation of samples. After sieving 10 mm wire mesh, and the subsamples will be collected and sieved in 2 mm wire mesh and 0.425 mm wire mesh for the initial soil analysis. Application of salt solution and fertilization. The application of salt solution will be to the potting medium prior planting of sweet potato cuttings. 1 week after planting, inorganic fertilizer will be added. If hosing the plants, the salt solution will be used if how many millimolar sodium chloride is assigned in each treatments. Planting. Cutting of sweet potato will be used measuring 30.48 centimeters. 4 cuttings of sweet potato will be planted per pot. Care and management. The watering will be done every other day or when it's needed. The water that will be used will be the prepared solution. Weeds in each pot will be removed manually immediately after the emergence of weed. Pests will be also removed by hand picking. Harvesting. 5 months after planting, sweet potato will be harvested. During harvesting, the sweet potato will be carefully uprooted. It will be bathed with tap water. After, it will be rinsed with distilled water, and it will be dried using paper towel, and it will be cut into several parts. The above ground or shoots, the below ground will be separated. If there's a fruit, it will be separated from the roots. Data to be gathered are plant height, number of nodes, fresh water of shoots or herbage, numbers of tubers, and fresh water of tubers. Plant height. This will be determined weekly by measuring the height from the soil surface up to the tip of the longest leaf until harvest. This will be calculated using the following formula. Plant height at 7 WAP, plant height at 1 WAP times 100 divided pH equals 6 weeks, where WAP means weeks after planting, pH means plant height. Number of nodes. This will be determined monthly by counting the nodes. Fresh weight of shoot or herbage. After it's being blood dried using paper towel, fresh weight will be gathered by using analytical balance. Number of tubers. This will determine after harvesting by counting the number of tubers. Fresh weight of tubers. Fresh weight tubers will be gathered by using analytical balance after it's being blood dried using paper towel. Soil analysis. Initial and final. Soil pH, soil organic matter, total nitrogen available, phosphorus, sodium content. After harvesting, the gathered soil subsample will be processed to determine the side effect of salinity to the growth of the sweet potato and the property of the soil. For the initial and final soil analysis, the following parameters will be analyzed: soil pH, soil organic matter, total nitrogen available, phosphorus, and sodium content. The study will be conducted outside or in the open field. Randomized complete block design will be used because outside environment is uncontrollable, and the example of which are temperature, relative humidity, weather, and etc. This study will have 3 replication and 6 treatment. Treatment 0 is unamended. Treatment 1 have 10 millimolar sodium chloride. Treatment 3 have 20 millimolar sodium chloride. Treatment 4 have 40 millimolar sodium chloride, and treatment 5 have 50 millimolar sodium chloride. Therefore, one is uncontrolled while the rest is controlled with different levels of salinity. Thank you for listening, ma'am, panel of judges, everyone. The floor is now open for your recommendations and questions.
References.